Hello, welcome back. In this segment we're going to talk about variables and data types and arithmetic operators in Java. I think everyone should already know what variables are if you have some programming concepts class or experience in your background. Variables are named locations in memory where data is stored, and each variable can hold one piece of data at a time. Variables always in Java always have a data type and a name, and they must be declared before they're used. So here are some examples of variable declarations in Java. For example, double is the data type and the variable is tax rate. And here's an integer variable called total and another one called count, which is initialized to 0. There's one called price that's initialized to 0.0, and grand total, which is initialized to 0. I'm going to flip back and forth between the Eclipse development environment and these slides so that we can kind of type into the Eclipse environment. So if we want a variable that can hold an integer value, we could declare an int variable. What is in the variable when it's declared before there's anything assigned to it? In Java, it is considered to be an uninitialized variable, and you can't use it for anything except to assign it to something. Let's output what's in variable, and it doesn't compile. So in Eclipse, if you hover over the red squigglies, you'll get an error message displayed to you. It says the local variable may not have been initialized. So let's assign something to it. Variable gets 10, and now that error message has gone away. So you declare the variables, and you must assign something to them before you can use them. Here's another variable, double tax rate. Notice that the variables start with lowercase letters, and they are correctly spelled English words. We're going to talk about the convention for naming variables in the next slides. Okay, so the syntax rules for declaring Java variables. You cannot put any spaces in a variable name, and you cannot start with a digit. So this MySpace variable wouldn't compile, and 7 days would not compile. Don't use reserved words for variable names. You can't have a variable called if, for example. And what characters can you use in your variable names? You can use all of the letters A through Z, you can use all of the digits 0 through 9, and you can use only 2 special characters, the underscore and the $sign. So these variables are syntactically correct. That means that these variables will compile. No, there's one mistake. You cannot use a %sign in a variable. That's a mistake. You cannot compile a variable name with any special characters other than $sign and underscore. So let's go back and declare some variables that are syntactically correct but wouldn't be very good choices for variable names. So we have 2 concepts here. We have the concept of syntactically correct and conventionally correct. So this one with several underscores and then $5, $6 is not a conventionally correct variable name, but it will compile. Okay, the naming conventions. For variables, you're going to start with a lowercase letter, always, and use mixed case for readability. So start with a lowercase letter and each subsequent word will be capitalized. This is called camel case. When you do that, I guess it's because camels have humps and you have humps in the middle of your variable names. When you're choosing the names for your variables, use correctly spelled English words. So here's a conventionally poor variable name, WSO321, because it doesn't describe what the variable is being used for. And convention is not style. You can't decide what your convention is. Convention is dictated as part of the language. This is one of Gosling's ideas, that everyone writing Java code will do it in a conventionally consistent way. Okay, let's start looking at assignment and arithmetic operators. So the assignment operator, which looks like an equal sign, we're going to pronounce this as gets. It's not an equality relationship, and we have another operator in the language that represents equals. So this assignment operator, we're going to say gets so that we don't get them confused. So if we have something called count samples, we're going to read this count samples gets 23. And if everyone does this the way they're supposed to, it means that the code will be easier to read when you're looking at someone else's work. Okay, the arithmetic operators in Java are plus, minus, multiply, divide, and modulus. And the first four should be very comfortable for you. You know how to add things and subtract them, multiply and divide. These are the symbols that we'll use in Java. Modulus we'll discuss separately because it may be new to you. So here's a little piece of Java code that says A gets 10 and B gets 6, and here's another int variable called result. If we write result gets A plus B, the value that's in A, which is 10, is added to the value in B, which is 6, and then the assignment happens and the variable result now has the value 16. Operators have a precedence, the same as in algebra. Plus and minus have lower precedence than the so-called multiplicative operators multiply, divide, and modulus. So in this Java statement we have A plus B multiplied by 3. The B times 3 happens first, so we would have 6 times 3 is 18, plus A happens second, and that would be 28, goes into the result. You can also use parentheses to change the order of operation in your arithmetic statements. So in this case, if we wanted the addition to happen first, we could say A plus B, which is 16 times 3, and whatever that is goes into the variable result. Okay, now let's look specifically at the modulus operator. Sometimes people call this modulo or just mod, and we think of this as the remainder operator. So if we have 10 modulus 3 or 10 mod 3, think of this as how many 3's can be taken out of 10 and what's the remainder. So this expression evaluates to 1. There are 3 3's in 10 with 1 left over. So 11 modulus 4, take out 2 4's from 11 and you have 3 left over. 11 mod 4 is 3. 1000 mod 10 is 0. There's a 0 remainder. And there are two special cases where you might get it wrong. The first case is where we have a smaller operand on the left than on the right. So how many 9's can you take out of 6? You can't take any, and the result is 6. So think of it as reducing the left-hand operand by multiples of the right-hand operand. And here's the other case that might trip you. If you have 0 on the right-hand side, this won't execute. It's called a divide by 0 error. Even though it's not really a divide, it won't execute. And in Java, if you try to execute something that won't execute, it's called an exception, or a runtime exception. Runtime exceptions interrupt the flow of control, the execution of the program, while compile time errors are a different kind of error. They prevent the program from ever running. So let's go into Eclipse and just declare a couple of variables. Here's A gets 10 and B gets 6, and then any name variable to put the result in, and we could write result gets A modulus B, and then let's print out the results. So system.out.println result, and there are no red squigglies, so it's compiling. And let's run this as a Java application, and we'll find out, well, here's a print line that output the value in variable, which at 10, and here's a print line that outputs the result of A modulus B, or 10 modulus 6. which is the remainder of 4. So let's look at an example where you try to execute a statement that has 10 modulus 0. And in this case, it's not a syntax error. There are no red squigglies. It is a runtime exception. So if we run this program, in the console window we have exception in thread main, and it's a divide by 0 exception. And it tells us that the problem is on line 15. So there's on line 15 at runtime. We failed to execute that line of code. So the arithmetic operators are what you would expect. So let's do a plus b times 3. What will the result be? We're going to do the multiply first because it has the higher precedence. B times 3, 3 3s are 9, plus a is 19, and just run that and make sure that it's doing what you expect it to do. So we have some int variables, and we are able to do arithmetic with them, and we can change the order of execution using parentheses. So in this one we should have 10 plus 3, which is 13 times 3, and I think that's 39, and it is. Okay, when you're using these print line statements, it would have been more useful if we had put a message in here to tell the user what we are outputting. So we're going to use the plus sign inside of the print line statements. So it's going to take this string, the result is, and concatenate it to, that's not an arithmetic operator, we're going to concatenate whatever is in this variable to this bit of text. So let's run that one, and that took a little longer than I thought it was going to. The result is 39. Okay, so that's more useful if we put some messages in our output statements as we're going along. So that's the modulus operator. It's the remainder operator, and it works pretty much like a divide, and then what's the remainder? So 10 divided by 3 is 3, and the remainder is 1. But it's what the expression evaluates to is the remainder. That makes it different from a division, obviously. Okay, so let's practice with arithmetic expressions a little bit. These can get arbitrarily difficult. Look at this one. A plus 3 times c modulus 2. Well, what happens first? Inside the parentheses will happen first 3 times c. So c has 5 in it. 3 times 5 is 15. What happens next? Well, the modulus operator happens next because it's multiplicative, even though it's on the right of the addition operator. So we have 15 modulus 2. What is the remainder of 15 modulus 2? It's 1. So then we have a plus the result of all this, which should be 11. And finally, the assignment operator happens. So we evaluate on the right-hand side of the assignment operator, and then result gets 11. Okay, when we're using integer variables, the result will always be an integer. So look at this example where we have result gets a divided by b, 10 divided by 4. You might immediately say, well, that's 2.5, but there can be no decimal point in an integer variable. So this is an integer division, and the division operator is said to be an integer division operator. So 10 divided by 4 is 2. The result must be an integer. That's quite different from floating point operators. So we have now a double variable, and double variables can have decimal points in them. So 10.0 divided by 4.0, and this time result variable is also a double. And if we do that division in floating point, we have a double result. So 10.0 divided by 4.0 is 2.5 this time. So the data type of the operands is deciding the data type of the operator. So in this example, we say that this is a double operator, and the double arithmetic functions quite differently than integer arithmetic for the divide operator. Okay, so what have we learned in this segment? It's very short. We have variables and data types, and in Java the two most common numeric data types are int and double. So if you have a variable that will not need any decimal points, you're expected to use the data type int, and if you have a variable that does need decimal points, then you're expected to use the data type double. We also in this segment looked at the rules for naming variables, the legal syntax for naming variables in Java, and the conventions. So we looked at using the underscore character and the $, which are legal in variable names, and then by convention we immediately don't use them. You'll understand more why that's true as we go along. So the conventions that are used when you're naming variables, they're not your style. You don't have a choice about this. And the purpose of these conventions are so that all Java code will look similar. And that will save you some time when you're looking at someone else's code. The assignment operator and arithmetic operators, including the modulus operator. And we also discussed briefly the order of operation in arithmetic expressions. The multiplicative operators have a higher precedence than the additive operators. That works the same as it works in conventional algebra. Integer division and double division, introducing the concept here that operators also have a data type. It's easy to understand that variables have a data type because you have to use the name of a data type when you declare them. But operators also have a data type depending on the operands that are used as the left and right part of the operator. Okay, this was a very short segment. We're going to move on to the remaining data types in Java and looking at the operators that are available on the remaining primitive data types.